You're going to ask that this tiny s can change everything? Well, yeah, it makes a lot of difference, and it is the reason that some websites have the lock icon and some others don't. Ladies and gentlemen, in this video, we will discover what is HTTP, what is HTTPS, and why HTTPS is better than HTTP. So, let's dive in. HTTP or Hypertext Transfer Protocol is the kind of protocol that allows transferring data between a web browser or a client and a web server. So it is like the language that a web browser and a web server talks to each other. HTTP follows a client-server model, where the client starts the conversation by sending an HTTP request to the server. Then this client will wait for an HTTP response from that server. So if I want to access Wikipedia, my browser sends an HTTP request to the server hosting that website and will wait for a response, which will be an HTML document that my browser will render and display. Not to forget, TCP/IP plays a big role in HTTP. They allow transmitting data for HTTP and routing it to the correct path. So let us describe what exactly happens in a request and in a response. So you want to enter a website called My Coffee Shop. Your browser will contact a DNS server or domain name system to find the IP address of My Coffee Shop. Think of the DNS as a giant phone book that has the IP address of different websites. Once your browser finds the IP address of My Coffee Shop, it will establish a TCP connection with My Coffee Shop server. Now your browser will create an HTTP request which contains the request method, the data requested, the user agent like Google Chrome, and what the browser accepts, like it can accept an HTML document. This request will be turned into TCP packets, where each packet contains a header specifying the source IP address, which is your IP address, and the destination IP, or the My Coffee Shop IP address. Those packets will flow from your network to your ISP and then to other routers and switches that will read the header and try to lead your packets to the closest route to their destination. Once arrived, the server will process that request and will send the following response. First, the status line, which indicates the language spoken, its version, and the status code, which means that the request was a success. Next, the content type, which is the type of the content that will be sent. Next, the content size, the server, the date, and some other information. Now, the response will follow the same path that the request did, but the difference is that the destination will be your address and the source will be the servers. Once your browser has the response, it will be able to render and display that website. Wow, we understood how HTTP requests and response actually work. How cool is HTTP, right? Well, there's a dark side. HTTP lacks encryption, which means all this data transferred is in plain text, which means they are visible. So any attacker who attempts to intercept your connection will be able to view your data. They can modify it, inject a virus, or steal it. This is why search engines are encouraging and prioritizing websites who are using HTTPS more than HTTP for security reasons. And this is why the not secure appears on the address bar when you access a website using HTTP. This is where we will introduce HTTPS, and this tiny s in HTTP changes everything. HTTPS is HTTP but with security. It utilizes a protocol like SSL but now known as TLS or Transport Layer Security. This protocol is based on a cryptographic system which encrypts data that is being transferred, offering a secure communication between client and server. So everything is similar to HTTP, like the request and the response, but what differs is that with HTTPS, data is encrypted. So instead of appearing in plain text, that data will be converted to a string of characters that can't be easily read and can only be decrypted by the same key that encrypted that data. So with the help of encryption, no one can see what data is being sent and received. So let's dive in to know exactly what happens when we add TLS to HTTP. Basically, TLS will use two types of cryptographic method. First is asymmetric cryptography, and the second is symmetric cryptography. Let us say Dave wants to send a message to John using asymmetric cryptography. At first, Dave will create a public key and will generate a private key that only Dave knows about it, which is the only key that can decrypt the public key. Dave will send that public key to John, which John will encrypt his message using that public key. So he will send it back to Dave, and using the private key, Dave will be able to decrypt the public key and obtain John's message. Now we covered the first method. Let us jump into the second method. Let us say this time Dave wants to use symmetric cryptography to send his message to John. Dave creates a key which he will share with John. Next, Dave will use his message and the secret key as input to the encryption algorithm, which will generate the ciphertext, which is the encrypted form of the message. Now remember, the secret key is only known between Dave and John, and should be kept as secret because it is the key who encrypts and decrypts the message. So Dave sends the ciphertext to John, which John will use a decryption algorithm and use the ciphertext and the secret key as input. After decrypting the ciphertext, John will have Dave's message. Now, how these two methods are used in TLS. Dave initiates the conversation between him and the server by sending a client hello message. The server then generates a public key and a private key, then sends to Dave its digital certificate with the public key. Dave verifies the certificate of the server using trusted certificate authorities. Once Dave knows that the server is not fraudulent, the initial handshake is completed. Next, Dave creates a pre-master key which he encrypts using the public key and sends it to the server. The server decrypts the public key and obtains the same pre-master key that Dave has. They both have the same pre-master key. Using it, they will generate session keys, which eventually Dave and server have the same session keys. Using these session keys, Dave encrypts his message using his session key and sends it to the server, which uses the same session key to decrypt the message. Now that you know how TLS works and how it is used to secure communication between client and server, you'll be more aware on which websites you visit by making sure they use HTTPS, not HTTP. Well, I hope you enjoyed this video, and I hope you got some value from it and learned something new. Make sure to drop me a like and subscribe to my channel for more tech-related content like this. Before you go, I have a question for you. Are you using VPNs? If not, you really need to check out this video. It will show you exactly why you need to use VPNs.